Welcome to the classifying rational numbers station. As you notice this week, we're broken up into stations. You get to pick the order you do things in. You just need to complete it by Friday. Today we're going to talk about classifying rational numbers, and I want to try to put it as simple as possible. But first, I want you to go ahead and pause the video because there is a sheet of paper in front of you of little flashcards, I guess, that you need to cut out. So go ahead and pause the video, cut those out, then press play, and then we'll continue. All right. By now, you should have cut out all those little flashcards, and those are going to come in handy at the end of the video. Once I'm done with this video, you will classify those flashcards with your group, and then there's a small little assignment attached to that, just some practice problems. And then you're done with this station, and hopefully you'll have a better understanding of what classifying rational numbers really is. So first, we're going to start. If you've already been to the folder station where you're building in your interactive notebook, some of this might look familiar. But first, we're going to draw a little diagram right here. Okay? Now, in the middle of classifying, you need to leave yourself plenty of room. In the middle of classifying rational numbers, you have whole numbers. Okay? That's your middle circle. Now guys, what is a whole number? You've been doing this since kindergarten. Well, you could use 8. That's a whole number. 1. I ordered 1 pizza. You could use 14. Those are all examples of whole numbers. Okay? Well, the next part of this circle that we're going to talk about is what we introduced, I don't know, pretty much the second week of school. Talk about integers. Now guys, I hope you guys can all tell me what integers are. And as you're drawing this, it doesn't have to be perfect. You can try, but it will be in your interactive notebook. Remember, you still need to take notes on all these videos and complete a whisk. Okay? Integers. Yeah. We got, -10. It's football season. Oh, hey, the running back, he ran for a loss of 4 yards. Loss of 4 yards. Oh, man, when I was walking to school today, I lost that $20 bill. Okay? You could do another one. -6. I spent $6 at Subway. So those are integers. Whole numbers and integers, guys. The last one is going to be the all-encompassing rational, can't spell, rational numbers. Now, I kind of created this backwards, but I want you guys to see, sorry, my phone went off. Someone calling from Rockport, Maine. Never even heard of that place. Okay, now we have the rational numbers. Now, before I start telling you exactly what fits in the rational number spot, I hope you can see this. This whole thing is rational numbers, and everything inside of it is rational numbers, followed by integers and whole numbers. So, the true definition of a rational number, a rational number, it can be written as a fraction. Okay? So, you can write a rational number as, it can be made into a fraction. You can also, it can be made into a simple decimal, like a terminating decimal or a repeating decimal. So, you don't have to write this part, but just take a look at this. I'm going to scoot this down real quick. Guys, here's the difference. A terminating decimal, actually no, go ahead and write this. I'm a liar. You can have a terminating decimal, which is this. What if I give you 1/4 as a fraction? Guys, that equals 0.25, 25 hundredths, right? It's a terminating decimal because guess what? That decimal just stopped, right? Now, a repeating decimal, we've talked about this in class, and you've seen it before, is, here we go. What if we have 1/3? You need 1/3 cup of flour to make that bread, okay? 1/3, what keeps repeating? The 3. So look, this keeps going on and on and on and on. That's a repeating decimal. Now, for the repeating decimal, we use the bar notation. That's a repeating decimal. Any number that you can make, the fraction can turn into a terminating decimal or repeating decimal, you can make it to a simple fraction, is a rational number. So some examples. Here we go. What if I give you like 8/10? Well, yeah, that can be made into a fraction, 8/10, right? What if I give you -1/2? We've talked about this. What's 1/2 as a decimal? What's half of a dollar? 50 cents, 0.5, right? So a negative would just be -0.5. Here we go. Look at that. 5 2/10 repeating. So what does that mean? 5.222222, right? So that's what? 5 2/9? That's what the fraction turns into, or the decimal turns into that fraction. Look, we're talking about thirds. You can just go like this. 5 1/3. My point is you do not need to do this. I'm going to color this in and show you. Everything in here is rational numbers, okay? I've heard this described a bunch of different ways. This whole outside area is rational numbers, okay? This whole outside area is rational numbers. And guess what? These are rational numbers too, but they're classified differently. Someone told me once that I want you to imagine the whole rational number, this whole system, is the Earth. So let rational numbers represent the Earth, okay? Now, as we're looking at us on Earth, we have the whole Earth as rational numbers. Let the integers, guess what that is? That's the bell. Integers can be North America, okay? Right? Or you can call it United States. The integers are United States. Now, what do you think whole numbers is? Where do we live? Yeah, Texas. So the whole number is Texas. Now, to make more sense out of it, if the whole number's Texas, the integers are the United States, and this is the world, aren't they all one and the same? Isn't Texas a part of the United States? Yes. Isn't the United States part of the Earth? Yes. The whole world? Yes. So, rational numbers is this whole thing. We are classifying rational numbers. So, as you're doing this, you can place these rational numbers in 6th grade. We're going to place them in 3 different spots. They can either be classified as a whole number, put them smack dab in the middle, right there in Texas. We can call them an integer, which is the United States, North America, right here. But if they're not an integer or a whole number, we're just going to throw that guy out here. You got it? Okay, so let's just do, well, we already did some examples. All right, as you can tell, I pressed pause and I used some amazing technology called Post-it notes, and I put it over here. What we're going to do is we're just going to practice, okay, because I want you to have this. I want you to have a visual. And the cool thing is, remember, it's a video, guys. You can go back and watch it again and again and again and again. Hold on, someone's calling me now. I'm sorry. Man, I apologize. Phone calling, bells ringing. Okay, so again, I took some Post-it notes, and we're going to practice classifying these, okay? So let's look at the first one. Let's look at this. Look what I have right here. -7. Guys, what would -7 be? We've learned this. -7 is an integer, which in return makes it a rational number. So where are we going to put it? We're going to put it in the integer circle. But since it's an integer, it's still a rational number. Do we get that? Remember, if this is the United States, it's still part of the Earth. Still part of the world, but we're just going to put it right there. Okay? Let's just go right here now. What about 3/7? What did I say at the beginning of the video? I said all fractions are rational numbers. So, can this fit in the whole number category? No. Integer category? No. Rational number category. And you know what? I apologize. I would even write that right here, guys. Put all fractions are rational numbers. You got it? All right, let's do a few more. What about -31? What do you think? Yeah, it's an integer. It's not a whole number, it's an integer. And it's not written in fraction or decimal form, so that's why we're going to put it in the integer circle. Again, it's still a part of the rational number family, I guess you could call it. What about this? It's a negative. So many of you might think, oh, integer, integer, integer. No, it's written in decimal form. And look, it's a repeating decimal. What keeps repeating? Guess before I tell you, please. What keeps repeating? Yeah, the 3 and the 6 keep repeating. Remember, we wrote this down here. Repeating decimal. So a repeating decimal, you can write that in fraction form, but we're going to classify this guy as just a rational number because it doesn't necessarily fit in the integer circle or the whole number circle. And finally, what about good old number 5? Good old number 5 is exactly that. It's just good old number 5. It's a nice whole number. Boom. All right. Guys, again, after this, you have those little flashcard things to work out as a group. You're going to write your answers on the back, and then you have an additional assignment. And I hope by the end of this whole station, man, you guys are experts at classifying rational numbers. All right. See you next video.